Hello everyone, welcome to Decode Aim. In today's video, we are going to solve the optimal solution of the two-sum problem that we were focusing in the previous two videos. So in the previous two videos, we have explored the brute force approach, in which we ran two loops and then followed the solution. Later on, I came up with sorting plus two-pointer approach, which was better than brute force but not the optimal solution. The brute force approach had brought us to order of n square time complexity. By doing sorting and then applying two-pointer technique, we reduced it to order of n log n. But this time we are going to reduce the time complexity of this problem to more. Like if I say we are going to use something called as HashMaps, and these HashMaps will reduce the overall problem's time complexity to order of n. Then you can see the overall reduction, how much we have optimized our problem to bring to the optimal solution, from order of n square to order of n log n, and later on to order of n. And we can say that here it is the optimal solution that we can think of. So now, first of all, before teaching you anything in the optimality, let me first tell you what do we mean by HashMaps. So like any data structure, like we have seen arrays till now. In the previous two videos, we were working on arrays. The problem we are solving is of array related. So HashMaps are also a data structure. It is also a data structure. And if you can see these two words, they say that data means something like information which is either regular information or something. But if we talk about a structure, it is something like a skeleton. So whenever we say that it is a data structure, it simply talks about how it is going to store, the data in the memory. Simple. How it is going to store the data in the memory will tell you what type of data structure we are using. So today we are going to talk about HashMaps. HashMaps are a type of data structure that works like that stores the data in key value pairs. What does it mean, key and value? So here, like in the previous solution also, we were doing something to store our location. We were creating something to store our location, or we were making the pair. We were making the pair of the address and the value in the sorting approach that we were doing. That's also a type of something we were trying to imitate the key value thing, but that was not the exact approach. The exact approach for this solution is this that we are going to focus on today. So what does key says? Key says the location, or in terms of this problem, the original location that the data was initially at, original location. And the value, simply the value that is present on that location. So now if I tell you about the intuition, what the problem can be solved in terms of HashMaps, then first of all, think of it like a container. We have a container. Wow, we have a container. So this container is storing the data values in terms of keys and value. Key and value. Now we have an empty container. Initially it is empty, and we will be taking it empty initially in the problem solution also. So initially we have an empty container, or we can simply say we have an empty hash map or dictionary in Python. Now we have the problem, supposing 2, 11, 15, 7, that the data we were following in the previous two videos. Now this 2, 11s, 15 and 7, we will run a for loop. This is going to be a very short video, as we already know all the approaches that we can follow, and this is the optimal approach that I'm going to teach you, and you will understand it more clear when you have gone through my previous two videos. So it is short because I've explained most of the problem in the previous two videos. This is just a solution, just an optimal approach that we can do and we should do after following the previous two approaches. So I will iterate in range of n, and you know n, what we were doing, the, you can say, length of the array, nums, you can say, wait, length of nums, and we were iterating over till there, length of n's. Now here is the thing, we know something, we have the target was 9 in this problem, like 2 plus 7 added to will give you 9, and then you will have to provide the location of that values that are present in the array, 2 and 3, 0, 1, 2, 3. We have the locations of the, we have the original locations that are in the array, a value that is placed at the locations. Now we have the target. Now think of something in terms of variables, like you can say we have variables, and if I say to you, I have x and I have y, I have a target, I have x, can I find y? Because the problem, what the problem was saying, the problem was saying that given an array of integers nums and an integer target, return the indices of two numbers such that they add up to the target value. Means we were adding them together. So if we are adding something, cannot we calculate the second value if we have been given the total sum and initial value, like 2 here? Cannot we calculate y? What I'm trying to say is that if you are adding something and you are getting the target, then suppose that you already have this value, cannot you get this? Simple, we can get this like target minus x. How do we get the value? If we do target minus x, then we definitely get the y value. Or you can simply say we get here 9 minus 2 as the 7, and you can see 2, if 7 is present somewhere, then we can simply say that the array contains that pair which are adding up to that target value. So what I'm doing here is that I'm creating a complement variable, complement or y or x, you can say anything. I'm creating a complement variable which is being calculated as target minus nums of I, and I am directly bringing the solution so that you can understand it more clearly. Alright, now what I'm saying here is that create a complement, get the complement by reducing that particular specific value at which I is pointing. Like in this scenario, initially I will be pointing at 0th location, so the value of nums of I will be 2. So what I'm doing here is that my initial, at the very first iteration value, I will have the target as 9 and the nums value as 2. Then I will reduce 2 from 9, which will be giving me the complement value as 7. So if I see here, I have I am doing this only in this particular code. Now I run the condition. If my complement, what I'm saying is that if my complement, now what is the use of this? I haven't used it initially because here I will be putting my memory, like something I'm trying to remember it. Because in HashMaps, let me tell you this one thing also, in HashMaps, deletion and getting the value and deletion, doing the simple operations, they take only nearly order of 1 time, so they take the constant time. So I'm saying that if I store something here, I can retrieve it back in order of one time, or I can say that in constant time. So it will not take much of time. Either it will take the storage, but it won't take much time to retrieve the value or restore the value there. All right. So I have it here. If complement is present in my something, the empty this container. So if complement present in my container, I'm saying here like container, I will come out with the code, or let me bring you the code instead. So in terms of container, what we were doing is that before the for loop, we were creating an empty dictionary of the numbers, empty dictionary of something. It was the empty of list, because we are creating, we were given their list of numbers. So we are creating an empty dictionary, and then we will run the for loop, and then we will see if this complement is present in that dict of nums. And bro, if this is present, which means if the complement is present in dict of nums, then give me the answer. But initially you can see there is no value stored. So if I run this approach and I get the true, then there I have to return the address. Simple as that. I have to return the address of the complement, where in the dictionary, empty dictionary, the complement is located. I'm writing it in short, and the ith index that I am putting. And then if I do not get the answer, which means I do not have the complement in my dictionary, then I have one line of code that will do my magic work, and that is store that complement thing. No, not the complement, store that x value, or you can say store the index value that we were iterating on. So what it will do, it will store the value which I were pointing to. So what we are going to add up in the code is that in dict of nums, store the ith value and give it the index also. So what it is saying is that in the key section you will get 0, as the original index in the array was 0 of value 2, and the value is 2. Now my code will run, and supposing that if nothing is going out, we already know it, we will return the empty array. So the code is completed. Now let us do the dry run of the code. What I'm saying is that it's okay. Now let's do the dry run. What I'm saying is that we have created the empty container, or empty dictionary you can say, and this empty dictionary, the hash map, is containing the key and the value section. Now I am iterating from I to something like n. You can say n is equals to length of nums, or we simply saying that we are iterating over the whole array. So initially I will be, let me put it here, 2, 11, 15 and 7. Initially I will be at the 0th location. I will be here, and then ith value is 2. Ith value, the value nums of 0, what it is saying is that it is saying nums of 0. So nums of 0, that is at the 0th location, what is your value? It is 2, and the target was 9. So the complement is 7. Now I am saying if my 7 is stored in the dictionary, so at the first iteration there was nothing, not even the 0 and 2. So it is not present, so it is false, it is not running inside the if statement. So what we are doing is that we are storing that value and the original location. What value? The value to which I was pointing. So we have stored 0, 2. Now again the iteration will run. I will come from here to the first location, 11. So here it will not be 2, it will be 11. 9 minus 11. 9 minus 11 says that is your minus 2 stored in the dictionary. If it is not stored, might be possible it can be needed in the future. If it is not stored, then return, if it is stored, then return the answer. If it is not stored, then store that ith value in that location, in that dictionary. So we are storing the index 1 value as 11. Now again we didn't get our answer, so my I is added to I is moved ahead with one more index, which is at the 2th location. So now once again I will check nums of I, which is 15. 9 minus 15, 9 minus 15 is minus 6. Is my minus 6 stored in the, is my minus 6, what I'm saying here is my minus 6 stored in dictionary of nums? No, it is not there. So store the ith value. So that might be possible in the future. We may need that particular value, and let me show you how we are going to get that. So dictionary of num will store the second as the storage, and in the value it will be 15. Now my dear friends, I will be pointing to its last location, which is the 3rd location, and in the 3rd location the value is, in the 3rd location the value is 7. The value is 7, and 9 minus 7 will give us 2. What I am saying here is that, bro, is my 2 stored in the empty dictionary or the dictionary that you have created? Is my 2 stored in the dictionary? And bro, yes, we have 2 in the dictionary. And as I said, the retrieval is in constant time. I can simply retrieve the index value, and literally this index value is the original index that the array value was present at. So yeah, here I get as the statement true, and I ran into inside the if statement. What I am returning here is that return the index where the complement was at, which means the complement was 2. It was it was at the index 0, which means the original location was 0, and return the ith index. Ith index means 3. So what I am getting here is my answer location, which is 0, 3, 0, 3. So my dear friends, I hope you got the answer, you got the solution, you got the most optimal approach we can solve this problem with which, and let me run the time complexity once again for this last one, how we said that we will be getting order of n time complexity. So you can simply see that this dictionary, yes, this is storing the value something. This is the storage, the data structure, and I said in my very first video that we are trading off the time complexity with the space complexity, as we have a lot of space but we have very less time to execute a problem or an algorithm. So yes, for I in range, it is reaching till n, so we can simply say that this loop is running till n times, so here I am getting as order of n. And now what is this? Every time this loop is running, it is doing complement of creating the variable in order of 1 time. It is the order of 1 time, and this one also, this one also, this one also, this one, it is just returning the empty dictionary. So actually we are doing here as single pass. We are doing here as single pass, and in the worst case, if I pass all the values, then in the worst case it will run till order of n times. The loop will run till order of n times in the worst case scenario. So my total complexity will be like this. Bro, order of 1, what? Order of 1 for lookup. Every time I'm looking up in the dictionary, I'm saying that is my value stored in the dictionary. So if yes or no, whatever it takes, it is doing this in order of 1. Then order of 1 for insert, it is order of 1 for the insert. Where we are doing insert? Here in the dictionary, it is putting the value in order of 1 time. Now the loop is running till order of n times. For loop, my for loop is running till order of n times. So if I say the total in the worst case scenario, if I'm saying that the dictionary has stored all the possible values and it has reached till the very end, and we might get the answer or might not get the answer, but in the worst case it is running till order of 1 plus order of 1 plus order of n times. So the highest is order of n, and in the worst case the time complexity is order of n times. All right, and I hope you have got my answer. I hope you have got my answer. And if I talk about in the terms of space complexity, then you can simply see that the whole dictionary is storing, in the worst case, the whole array values which are till n. So in this case also, in the worst case, order of n times, it is storing every possible element, every element in the array every element of the array. So now let us come towards the solution and solve this problem. Let's complete the problem and move towards the next problem in the next video, but let me give you the solution. So we have the nums as the array, or you can say list of integers. We have the target value, and now what I'm doing here is that I'm creating an empty dictionary as dict of nums and initializing it to something empty. Now for I in range, what we were doing, we were calculating the range of length of nums to iterate over the whole array, and we were calculating in each instance, we were calculating the complement by doing what? We were reducing the nums of I from the target. And if we get this answer, as true, I'm really sorry about that. If my complement is in the dictionary of nums, then definitely it is present and I got my solution. Then I return the index. I'm returning the index like dict of nums complement, where the complement is present, comma, ith location. So what it will be return? It will be returning like 0, 3, or in this case we are here at 0 and 1, so it will be returning my answer as 0, 1. So let us write the further code. Dict of nums as nums of I, and we are storing. If the statement is not running, then definitely that value might be needed in the future. So let us store that index value or that of the array, and if nothing works out, return the empty array. So now let us test the code. If it works, fine. And yes, my dear friends, we have got the answer as the expected value of the output. Now let me submit the code and see how much we get the time complexity and how much people we beat. So we are beating up 57.72%. It's because I have put something, or I have not done my code in the right, I am not beautifying my code, definitely. So if I do something like we have the beautify option here, might be all right, it's okay, but we can beautify it. We can create the length of nums and put it into the n, and then we will be increasing this. But what I'm saying is that the runtime, see the runtime is exactly 1 millisecond, so which is very much lesser than in comparison of brute force approach as well as the sorting plus 2-pointer approach we were using. But here the memory got reduced as it is taking 18.90 MB, which if we analyze it, it is taking much more memory in comparison to the others, as other were memory efficient but not time efficient. But this algorithm is time efficient, as the time is the most important thing in most, you can say most of the problems, time is the most important thing. So that was my solution, and we have ended up our two-sum problem here. Now from the next video I will be coming up with the next amazing problem in our 150 DSA problem series. Till then, I wish you good luck in this journey, and I want you to watch all the videos at your pace. Whatever it takes, we have to complete this whole series, and I definitely assure you that you will love solving problems after this whole playlist. So please, my dear friends, copy the playlist or save it in your library and share it with your friends, because sharing is caring. All right, so that's all for today. I am signing off. Thank you for watching. Bye.